So in this video, we'll continue talking about classes. In particular, we'll talk about our ball class here that we have. So it's still on our classes project, playground project, that is. Previously, we talked about how to create a class and how to instantiate objects off of classes. As you see here, we have properties and we have behaviors. And then here we are creating an instance of the class ball, which means we're creating an object. We created another object, basketball of type ball, soccer ball of type ball. All of these share the same template, which is our ball class here. And of course, we went ahead and accessed using the dot notation properties of our class, added values to them, in this case size and color, and then we printed them out. So we saw the states of our objects as we instantiated them and added values. Now we need to talk about initializers. So when we want to talk about initializers with classes, we need to think about the states of our objects when they are created. In other words, when we instantiate an object, as we've done here in this line here, right? In the beginning, the object has nothing per se, right? Because if you look at this class here, the properties, color and size, so we kind of forced the initialization of these properties here, which is fine. But in a more robust way of creating classes, we need to find a way that we can internally, when the objects are indeed created, we want to make sure that those objects, they at least have certain default states. Okay? Think of it. So as we said previously, if you think back of what a class is being a template is not necessarily the actual thing. Meaning, if I say, for instance, a blueprint of a house, it's not necessarily a house, right? In order to actually have a house, you have to actually build the house using those blueprints. So in this case, this ball here, it's just an abstract representation of what a real ball would do or would look like. As such, as we instantiate, as we create objects, as we see here at the bottom, so basketball, soccer, my ball, as we create those objects, we want to make sure that they have a certain state, they have certain properties, okay? So Swift actually allows us to initialize our objects in a way that anytime object is instantiated, it already comes with predefined, if you will, or default values that will make them real world objects. Meaning, a ball without a color or a size wouldn't make any sense in the real world, right? Because if you think of a ball, it has to have at least a size and usually has to have a color. That's what makes a real ball, okay? So the way we initialize an object, or at least the template, so that when the object is created, there's some initial values, we just go ahead and say init. As you can see, there it is, our keyword, enter, and then we have our braces there. So inside here, that's when we can initialize values, in this case properties, or anything else we want, but in this case it's just going to be properties of this class here. So while we're here, let's go ahead and comment all of this out here we've been working on. Command exclamation point key, okay, and give it a lot of space here. So now to initialize that, what we can do, as you can see at the top in the properties here, we went ahead and say color, it's type of string, give it an empty string, okay? But now let's get rid of this. Let's go ahead and get rid of that. We're gonna have a problem if you click here, return from initializer without initializing all stored properties. So we're having a problem again because it's saying, well, these properties are not initialized, so that's a problem. Inside here, what we can do, we can then initialize our properties here. So say color is equal to, say blue, and go ahead and say size. Now, notice what's going to happen. If I go to my ball here and say dot notation and hit size, look, we have 12. Because we're saying here in our initializer method here, we're saying that size field or property, okay, we want it to be 12 when this object is created. And we want also the color to be blue. So if we say color here, we should see blue. So now we know this object here, internally, we know it is initialized. And the other thing to notice here is that our init method here, well, for once, it's a function, it's a method, it's an instance method, right? Because it's inside of a class, we call them instance methods. Same thing as function, but just terminology, okay? we can actually pass in arguments as well. If we want to pass arguments here, which means when we instantiate the object outside, okay, we'll have to pass values inside of our class here. Meaning, let's go ahead and say here, color of type string. I'm going to say size, also size of type int. Now you notice right away we have a problem here. If you click on this red button here, cannot invoke initializer for type ball with no arguments. It's saying, well, you told me to create an instance of this object, this class here, to create an object, but this class here, the blueprint, has an initializer that requires to pass arguments. Okay, it is a contract. So now we need to go ahead and say color and give it, say, green, and size, let's give it 45. Okay, there we go. But now notice we have a problem here. Let's go inside of our init. We have color. If you click in here, it says mark parameter with var to make it mutable. So it's saying if we want this to work, we need to make this var, this parameter here, var. That way we are able to do this. Now here's what's happening here. You notice we have color and we have size. And you notice here as our properties, we have color and we have size. One thing we need to pay close attention here is that what's happening, this color here, variable here that we are passing in blue, is not this color outside, which is the property, which is exactly what we need. The reason why this color here is not exactly, the one outside is because these are in different scopes. The thing we need to do here, we need to use a different keyword called self.color. Now, if you click, just notice how things change here. If you click on the color, look, this is kind of highlighted here as well. Because now what's happening, we're saying self. This self keyword here refers to our class ball. Would be the same as saying ball.color. Okay, but we can't do that. We have to go ahead and say self because that's not an object yet. So the self here, we're referring self as me, in this case, this whole class here, .color. So we are accessing this class's color property. And then what we can do, because we are accessing our color property, then we can just pass what we are passing in our init method here. Let's say color. And we can do the same with our size. So self.size, instead of just hard coding the 12, we can just pass in the size. Okay. And now this class, it's becoming more and more dynamic. So now here, if you go to create instance of the class, we can say var my ball is equal ball, and then we pass in these values as arguments. Now this class here, if we get rid of these values that we passed, we're going to have an error because again it's saying, well, since I have an initializer, the initializer has parameters that we have to pass. Again, that's a contract and you're not passing anything, therefore I'm not going to compile. Something is wrong. Okay, so let's put that back. So there we go. So here we have initialized our class. And there it is. And again, I would like to let you know that I know this may sound really difficult. Like, oh my goodness, it's so difficult. Some of you may feel as if there's no need to learn all of this because it's just, when are we going to use it and why? At a later time, we'll start using classes. But the main reason why you need to understand classes and object-oriented programming, because Swift is highly object-oriented programming, as we have spoke earlier. If you look at all of, for instance, the UI color or UI image for that matter, that's a class, right? You can see there's a class, there's methods, and there's so forth. So everything was built using object-oriented programming thought process, which allows us to leverage our applications in ways that are more sustainable, more flexible, and more efficient. All right, so good. So go ahead and study a little bit this ball class here and create your own classes. And the way you think of a class, if you want to figure out, for instance, what makes a class in the real world or abstractly speaking, anything that is a noun can be a class. A ball, as we saw here, is a noun, so you can represent that as a class, right? For instance, a dog is a noun. You can represent that as a class. A car is a noun. That could also be represented as a class. So anything that is a noun can very well be represented as a class. Perfect, great. So I'll see you in the next video.